Good day, everyone. Hi, my name is Kim Ira Luis Kalubakib, and my partner Naomi Kabiko will present the lesson 9, which is wiring methods. At the end of the topic, you would be able to know the wiring specifications and installation requirements based on the NEC and/or PEC. To start our discussion, let's have our introduction first. In a commercial building, the major part of the electrical work is the installation of the branch circuit wiring. The engineer must have the ability to select and install the correct materials to ensure a successful job. For some jobs, the specification or bid documents will dictate a specific wiring method that is required. For residential installations, the architect or engineer will specify the wiring method to be used. Conduits. Electrical raceways are paths that enclose conduits and wires. The conduit pipes can also be referred to as a duct, tube, channel, gutter, or trench. The conduit is designed and used expressly for the purpose of holding wires, cables, or bars. The purpose of electrical conduits are the following. A. Provide means for the running of wires from one point to another. Second, physically protect wires and wiring system from damage and elements. Third, provide grounded enclosures. And lastly, protect the building and occupants from electric shock or damage. Here are the type of conduit. Rigid metal conduit RMC and intermediate metal conduit IMC. These are heavy-duty and rigid metal tubing used for structural applications. They are mostly used outdoors. Both type of the conduit may also protect the wiring going into and out of the service panel. RMC and IMC can be used interchangeably, but RMC requires pipe fittings, and IMC is more common as it is lighter and easier to work with. So, sa dalawa na to, IMC ang mas common kasi mas madali at mas magaan siyang gamitin. Our second conduit are electrical metallic tubing or EMT. This is the most common electrical conduit for exposed interior installation. This may include unfinished garage or basement. EMT is the thinnest and lightest of the rigid metal conduit pipes. These come in different diameters. It is also called thin wall and is easy to bend with a tool called conduit bender. The National Electrical Code or ENC permits EMT for dry and wet locations, but it requires special water light fittings and connector in wet locations. Our third conduit or flexible metallic conduit or FMC. This conduit is a spiral metal tubing that bends easily. It is commonly used for short and exposed runs in household circuits. This may include hot water heaters, garbage disposers, and furnaces. FMC is ideal to use in dry locations only. Flexible metallic conduit may also be used as a ground path with approved fittings. Liquid tight flexible metal conduit or LFMC. This is a flexible metal conduit coated with a plastic sheeting. This conduit is a water and moisture proof. LFMC may be used in dry as well as wet locations. This is commonly used to protect the wiring between an outdoor air conditioner unit and the disconnect switch. LFMC may also be used underground if the materials are approved for the application. Rigid polyvinyl chloride or PVC. It is a plastic tubing that is thinner version of PVC plumbing pipe. It can be heated and bent to change direction and is more commonly routed with elbow fittings. All the connections are solvent glued, which make the conduit waterproof. Rigid polyvinyl chloride may be used for outdoor and underground applications. It is also ideal in dry and corrosive locations. High-density polyethylene conduit or HDPE. HDPE is a highly flexible plastic material that is waterproof and offer corrosion and chemical resistance. It is durable and available in long reel lengths to reduce joints and installation time. HDPE conduit are also available in variety of sizes, colors, dimension, and lengths. It does not require bending tools or elbow fittings. Here are the maximum number of wires in a conduit. The allowable number of wires that can be placed inside the conduit varies according to the type and size of the conduit, and also on the size of the conducting wires. Wire size is defined by the American Wire Gauge or AWG number. For example, THHN and THWN, the most common wire used in residential wiring, will use the following conduit fill table. As you can see, nasa baba yung table na nandito lang yung complete list of the tables na available sa NEC or PEC. Wire connectors are known in the trade by such names as screw terminal, pressure terminal, connector, wire connector, wing nut, wire nut, Scott clock, twister, split bolt connector, pressure cable connector, solderless lug, soldering lug, solder lug, and others. Which is solder type lugs and connectors are rarely, if ever, used today. So, hindi na siya masyadong ginagamit as of today. In fact, connection that depend on solder are not permitted for connecting service entrance conductor to service equipment. Solder is also not permitted for grounding and bonding connections. So, split bolt connectors are used for connecting two conductors together or for tapping one conductor to another. They are available in sizes 10 AWG through a 1000 circular mill. They are used for two solid and or two stranded conductors only, unless otherwise noted on the connector or on LTS shipping carton. So our next wire connectors are crimp connectors. It's a type of shielded electrical connector used for terminating stranded wire and also used to splice and terminate 20 AWG to 500 kC mil aluminum to aluminum, aluminum to copper, or copper to copper conductors. So, our connectors naman is used to connect wires together on combination of 18 AWG through 6 AWG conductors. They are twist on solderless, and tapeless. Wire nut, wing nut, and twister are registered trademarks of Ideal Industries. Scott clock is a registered trademark for 3M. Connectors used to connect wires together in combination of 16, 14, and 12 AWG conductors. They are crimped on with a special tool, then covered with a snap-on insulating cap. Solderless connectors are available in sizes 4 AWG through 500 kcmil conductors. They are used for one solid or one stranded conductors only, unless otherwise noted on the connector. The screw may be of the standard screwdriver slot type, or an Allen wrench or socket wrench. Compression connectors naman are used for 8 AWG through 1000 kcmil conductors. The wire is inserted into the end of the connector, then crimped on with a special compression tool.
Permissible connection in boxes. The pull box is a box with a blank cover that is inserted in one or more runs of conduits to help in pulling in the conductors. It may also serve to distribute the conductors. The junction box allows distribution of wires but that is not connected to the lightning or outlets. The box protects the connection, which usually contain vulnerable points such as wires, splices, from environmental conditions and accidental contact. The conduit and tubing size required for non-installation depends on three factors. A. The number of conductors to be installed. B. The cross-sectional area of the conductors. C. The permissible conduit fill. This table below shows the allowable number of conductors inside boxes: octagonal, square, and switch. Octagonal box with telescopic hanger and extension. This shape is better than a square box for matching the round bases of light fixtures so that the box is easily hidden when the light fixture is installed. Square box. Square boxes are used where multiple conductor runs are split into two or more directions to bring power to a number of electrical devices. Utility boxes are above-ground structures that house electrical transformers, electrical switches, cable TV, communication or telephone connections and wiring, and other electrical connections required to distribute a utility service from a main line to individual buildings. A conductor loop or coiled less than 12 inches through box is counted as one conductor. Kapag ang conductor loop or coiled ay less than 12 inches, ay counted ito as one conductor. If the loop conductor is 12 inches or longer, these are counted as two conductors. Kapag naman ang loop conductor is 12 inches or longer, counted naman ito as two conductors. One or more equipment grounding conductors entering the box is counted as one conductor. Each conductor originating outside the box and terminating inside the box is counted as one conductor. Transformer wires in the box are treated as containing four conductors. Luminaire will only be counted as additional conductors if not more than 4 luminaire wires and size smaller than 14 American wire gauge, since the conductors in the figure are size 14 American wire gauge and there are 4 conductors counted. The wiring guidelines. The usual wiring system is a centralized distribution type system in which conductors of progressively smaller size emanate radially from one main panel to the distribution points. These distribution points are switchboards throughout the system, which provide the overcurrent protection via circuit breakers, CRB, for each of these branch. An alternative would be to use a decentralized system where smaller circuit breakers would be placed in each location. The purpose of this second arrangement is to eliminate the branch circuit wiring by placing the protective device at the load. By eliminating branch circuit wiring, installation costs are reduced, voltage drop and energy losses in branch circuit conductors are negligible, and loads are individually protected. All guidelines are based on the NEC and PEC or Philippine Electrical Code and referred to as the code. The first code is wiring shall be types RHW, RHH, T, THW, TW, THWN, THHN, and XHHN. The second code is lighting and receptacles should not be combined in a single circuit. 3. Lighting and receptacles should be supplied with current from at least two circuits so that if the single line is out, the entire area is not deprived of power. 4. Do not allow combination switch and receptacle outlets. Next, provide switch control for closet lights. Pull chain switch is nuisance. 6. Convenience receptacle should be planned properly, so that in case of failure by any one of the circuitry, the entire area will not be deprived of power. 7. All kitchen outlets should be fed from at least two circuits. Kitchens should have a duplex appliance outlet every 36 inches or 0.90 meter of counter space, but no less than 2 in addition to the normal wall outlets. The code requires a minimum of 2 amperes appliance branch circuits to feed all the small appliance outlets in the kitchen, pantry, dining room, and family room, and only these outlets. Furthermore, all kitchen outlets must be fed from at least 2 of these circuits. 8. In bedrooms, supply 2 duplex outlets at each side of the bed location to accommodate electric blanket, clocks, radios, lamps, and other such appliances. In rooms without overhead lights, provide switch control for one half of a strategically located receptacle that is intended to supply a lamp. 9. Convenience outlet, though counted as part of the general lighting load, shall be limited to 6 convenience outlets on a 15 amperes circuit and 8 convenience outlets on a 20 amperes circuit. Next, provide a special separate circuit for heating and air conditioning units. 11. Additional circuits similar to appliance circuits should be furnished to supply one outlet in each bedroom of a house that is not centrally air conditioned. Such outlets are intended for window air conditioners. 12. The code requires sufficient circuitry to supply residential load of 30 watts per square meter in buildings including porches, garage, and basements. 13. The requirement of 30 watts per square meter is up to 80 square meter for a 20 ampere circuit or 2400 watts, or 60 square meter for 15 ampere circuit or 1800 watts. 14. Good practice suggests that the load should not exceed 1600 watts for a 20 ampere circuit and 1200 watts for 15 ampere circuit. Thus, A. Observe a maximum load of 1200 watts on a 15 ampere circuit with a maximum area of 40 square meter. B. Observe maximum load of 1600 watts on a 20 ampere circuit with a maximum area of 53 square meter. 15. The general purpose branch circuit should be rated at 20 ampere circuit, wired with a 12 American wire gauge being the minimum size of conductor wire required for all convenience outlets. And last one, provide at least one receptacle in the bathroom and one outside the house. Both must be ground fault circuit interrupter GFCI type. This table shows branch circuit requirements of minimum size of conductor, minimum size for taps, overcurrent device rating, lamp holders permitted, receptacle rating permitted, and maximum load. And the second table shows branch circuit capacity, electric heat aircon circuit breaker size. And that's for all today. Thank you for listening.